Okay, so today we are going to be looking at sketching some graphs, specifically exponentials and logarithms. So we're looking at trying to sketch y equals a to the power of x, y equals a to the power of negative x, and y equals log a of x. So the learning intention is the knowledge of the shape and the appearance of these exponential and logarithmic graphs, and we'll be successful if we can sketch an exponential graph, sketch the logarithmic graphs, and be able to translate and transform these graphs around the Cartesian plane. So let us start. Alright, we're going to start with sketching y equals 2 of x. Okay, and so I'll do this with black. Okay. So this means, I'm going to start with 0, so this is 2 to the power of 0, well, anything to the power of 0 is just 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, and 2 to the power of 3 is 8, 2 to the power of negative 1 is a half, 2 to the power of negative 2 is 1 over 2 to the power of 2 is 4, and then to negative 3 is going to be 1/8. Alright, so there's 1, 2, 3, negative 1, negative 2, negative 3. Okay, so we've got 0, we've got 1. 1, it's 2. At 2, we've got 4. And at 3, we have 8. Negative 1, we have a half. We then have a quarter and an eighth, so it keeps decreasing but will never touch the x-axis. So what ends up happening is we have this graph, this exponential graph, where it's growing. It's an exponential growth. Yeah, that looks like that. Okay, so this represents exponential growth. Alright, so if we have y equals 2 to the power of negative x, so same thing, so that became 0, so it's 1. 2 negatives, if it was negative 1, becomes a positive, so 2 to the power of 1 is just 2. And then we get 4 to the power of negative 3, 2 negatives become positive, so 2 to the power of 3 becomes 8. We've got a half, a quarter, and 1/8. So 0 is 1, negative 1 was 2, negative 2 is 4, negative 3 is 8. Then we've got a half, a quarter, and 1/8. And what we have, it looks like some exponential decay. Yeah, as the x increases, it's getting smaller and smaller and smaller. Okay. Yeah, so when you have a negative, it reverses, it flips around the y-axis. Alright, let's look at sorry, y equals log 2 of x, okay? So remember that this x is basically the answer, yeah? So 2 to the power of what becomes x? So, okay, if I want it to equal 1, that has to be 0. So 2 to the power of 0 equals 1. That's going to be 1. 2 to the power of 1 equals 2. Yep, because that's your x value there. So we're trying to think basically 2 to the power of 2 becomes 4, and then 2 to the power of 3 becomes 8, so it's going to be negative 1, negative 2, and negative 3. Okay, so notice that this is flipped. So y equals 2 to the power of x, the reciprocal or the inverse is y equals log 2 of x. Okay, so when x equals 1, I shall get to 0. When x equals 2, I should get to 1. 4, I should get to 2. And then for 8, I should get to 3. At a half, I should get to negative 1. A quarter, I should get to negative 2. And yep, so I should get something that looks and there's your log 2 of x. Yeah, and as I said, this is the inverse of this and vice versa. Yeah, and they reflect about the y equals x axes. Yeah. Okay, let us now sketch e of x. Okay, so anything to the power of 0 is going to be 1. E has a value of 2 so if we go shift log, we get the E. So Euler's number is around 2.71, so I'll just actually to one decimal place. 2.7, I square that, 7.4, if I cube it, I get 20.1. Okay, to negative 1, I get 0.4. Negative 2, I get 0.1. Negative 3, 0.05. Okay, so we get so a rough sketch would be of y equals e to the x would look like that. Okay, and obviously of the log of x, well, if I do log 0, we get a math error. Yeah, because remember that this is log e to the power of something gives us 0. And that just doesn't happen because we do not touch the x-axis. Okay, where log of 1 should be 1. Sorry, should be 0. Log of 2 is 0.7. Log of 3, 1.1. Log of 4, we get 1.4. So So y equals log of x, or natural log, would look like that, and these are inverse. Yep. So these are inverse of each other. Okay. Right, so that's what the shapes look like. Let's now look at what happens when we move it around the Cartesian plane. Okay, so if we have y, this is using decimal, this is what y equals 2 of x, notice that if I place I add a constant, let's say 5. Yep, I'll do it 3. It shifts the graph up by 3 units. And if I subtract, it will shift it down 3 units. If I place a value in front of the x, let's say 5. So this is that was my original curve, and this is my change. The graph gets narrower, yeah, or the rate of change increases. If I have it over a fraction, yeah, it gets flatter. Okay, so the rate of change slows down. If I add a constant to the power, right? So, okay. What happens, so if it's a positive power, it moves it. I'll change it to 1, right? It moves the whole graph to the left by 1 unit. Yeah. And if I subtract it, it moves it to the right. Okay. So, if you get like to the power of x, and then you add a constant that moves it up by k units. If I subtract it, it moves it down by k units. Okay. This, if b is greater than 0, it makes the curve more narrower as the rate has increased. And is so greater than 1. If it was a fraction between 0 or 1, it makes the curve flatter as the rate is a little bit has slowed down. Okay. If it's at to the power, it shifts or translates to the left C units. And if it's subtraction, it translates it to the right C units. Okay. Now let's look at our log of a of x. Okay. Let's say log 2. So that's log of x. Okay. Alright. If I obviously add a constant, such as that, it translates it up 3 units or up those many units, and if I subtract it, moves it down. Yeah. If I place a variable at the front, obviously, and it's greater than 1, it kind of flattens out, but if I have it as a fraction, it makes it narrower. And if I add a constant in here, it shifts it to the left those many units. If I subtract it, it shifts it to the right. Okay. So this moves up k units. That moves down k units. Okay. If b is greater than 1, it's flatter. So it looks more like that. And if it's between 1, it's much narrower. Yeah. This translates it to the left. C units. And this translates it to the right, C units. Okay. Thank you very much.